Hello students, let us discuss about data mining architecture. In this lecture, we are going to see what is data mining, what are the building blocks of data mining architecture and what are the various types of data mining architecture. First, let us start with data mining. The data mining refers to extracting or mining knowledge from the large amount of data. It is also referred as knowledge discovery in databases. Next, we are going to see the architecture of data mining system. The architecture and design of data mining system is important for data mining system. A good system architecture will facilitate the system to make best use of the software environment to accomplish data mining tasks in an efficient and a timely manner. Data warehouse is the initial source that contains internal data used to track all user information coupled with external data. Various relational databases are used for the implementation of warehouse as well as for flexible data access. OLAP, Online Analytical Processing Server. OLAP defines the end user model for the data to be applied while navigating warehouse. The multi-dimensional view analyzes the data, present the view of business, summarize the product design and line and other perspectives of business. Data mining server must be embedded with data warehouse as well as OLAP server to analyze business. It includes process centric metadata that defines the objectives for business issues such as prospecting, promotion and campaign management. As the data warehouse size increases with new results, the firm can continuously practice the best decisions and apply them in future. The advanced analysis server take references of users' business models directly to warehouse and results into proactive analysis of information. These new results enhance the metadata storage in OLAP server and represents distilled view of data. Other analysis tools such as reporting, visualization can be applied to plan future actions. Data mining is a very important process where potentially useful and previously unknown information is extracted from large volume of data. There are a number of components involved in the data mining process. These components constitute the architecture of a data mining system. The major components of any data mining system are: 1. Data source, 2. Data warehouse server, 3. Data mining engine, 4. Pattern evaluation module, 5. Graphical user interface and 6. Knowledge base. We will see the major components one by one. First, data sources. Database, data warehouse, World Wide Web WWW, text files and other documents are the actual sources of data. We need large volume of historical data for data mining to be successful. Organizations usually store data in databases or data warehouses. Data warehouses may contain one or more databases, text files, spreadsheets or other kinds of information repositories. The data may reside even in plain text files or spreadsheets. World Wide Web or the internet is another big source of data. So, what are the various types of data sources? There are a range of data sources. Each type will require different data modeling techniques. First, unstructured data sources. Unstructured data sources are data sources missing a logical data model. A data source where no particular logic and structure is defined to collect, store and expose it, it is called unstructured data source. The example of an unstructured data source is a written document. That document has a lot of information in it, but there is no structure that defines and codifies how information is stored. There are some data modeling techniques which derive structured data from unstructured data. This kind of analysis is becoming popular as companies seek to use social listening to understand sentiment on social media. Next, we will see about structured data sources. Structured data sources are highly organized. These kinds of data sources follow a specific data model, and the engine which makes the storing activity is programmed to value this model. A well-known data model behind structured data is relational model of data. In this model, each table has to represent an entity within the considered universe of analysis. Each entity will then have a specific attribute within each column and a related observation within each row. Finally, each entity can be related to the others through key attributes. Consider an example of a relational database of a small factory. Within this database, we have a table recording all customers' orders and one table recording all shipments. Finally, a table recording the warehouse's movements will be included. Within this database, we will have the warehouse table linked to the shipment table through the product code attribute. The shipment table linked to the customer table through the shipment code attribute. The advantage of this model is the possibility to easily perform queries within tables and merges between them. The cost to analyze structured data is lower than the one to be considered when dealing with unstructured data. Next, different processes involved in data mining architecture. The data needs to be cleaned, integrated and selected before passing it to the database or data warehouse server. As the data is from different sources and in different formats, it cannot be used directly for the data mining process because the data might not be complete and reliable. So, first data needs to be cleaned and integrated. Again, more data than required will be collected from different data sources and only the data of interest needs to be selected and passed to the server. These processes are not simple and number of techniques may be performed on the data as part of cleaning, integration and selection. Next comes database or data warehouse server component. The database or data warehouse server contains the actual data that is ready to be processed. Hence, the server is responsible for retrieving the relevant data based on the data mining request of the user. The third major component is data mining engine. The data mining engine is the core component of data mining system. It consists of number of modules for performing data mining tasks as shown. The tasks are characterization, association and correlation analysis, classification, prediction, cluster analysis, outlier analysis, evaluation analysis. The fourth component is pattern evaluation module. The pattern evaluation module is mainly responsible for the measure of interestingness of the pattern by using the threshold value. It interacts with the data mining engine to focus the search towards interesting patterns. Next component is graphical user interface. The graphical user interface module communicates between the user and the data mining system. This module helps the user to use the system easily and efficiently without knowing the real complexity behind the process. When the user specifies a query or a task, this module interacts with the data mining system and displays the result in an easily understandable manner. Next one is knowledge base. The knowledge base is helpful in the whole data mining process. It might be useful for guiding the search or evaluating the interestingness of the result patterns. The knowledge base might even contain user beliefs and data from the user experiences that can be useful in the process of data mining. The data mining engine gets input from the knowledge base to make the result more accurate and reliable. The pattern evaluation module interacts with the knowledge base on a regular basis to get inputs and also to update it. Each and every component of data mining system has its own role and importance in completing data mining efficiently. These different modules need to interact correctly with each other in order to complete the complex process of data mining successfully. Next, we are going to discuss about various types of data mining architecture. Data is collected through business transactions and stored in relational database systems. Also, these business processes have been built to provide analytical reports, that is, for business users to make decisions. The data can be stored in database or data warehouse system. So, data mining system should be designed to decouple. Various types of data mining architecture are: number 1, no coupling data mining; number 2, loose coupling data mining; number 3, semi tight coupling data mining; and finally tight coupling data mining. First, we will see about no coupling data mining. In this architecture, data mining system does not utilize any functionality of a database or data warehouse system. A no coupling data mining system retrieves data from a particular data source such as file system, processes data using major data mining algorithms and stores result into the file system. The no coupling data mining architecture does not take any advantage of database or data warehouse that is already very efficient in organizing, storing, accessing and retrieving data. The no coupling architecture is considered a poor architecture for data mining system. However, it is used for simple data mining processes. Next comes loose coupling data mining architecture. In this architecture, the data mining system uses the database or data warehouse for data retrieval. In loose coupling data mining architecture, data mining system retrieves data from the database or data warehouse, processes data using data mining algorithms and stores the result in those systems. This architecture is mainly for memory based data mining system that does not require high scalability and high performance. Next architecture is semi-tight coupling data mining. In semi-tight coupling data mining architecture, besides linking to database or data warehouse system, data mining system uses several features of database or data warehouse systems to perform data mining tasks including sorting, indexing, aggregation. In this architecture, intermediate results can be stored in database or data warehouse system for better performance. Next architecture is tight coupling data mining architecture. In tight coupling data mining architecture, database or data warehouse is treated as an information retrieval component of data mining system using integration. All the features of database or data warehouse are used to perform data mining tasks. This architecture provides system scalability, high performance and integrated information. Next, we are going to discuss the 3 tiers in tight coupling data mining architecture. First layer is data layer. The data layer can be a database and or data warehouse systems. This layer is an interface for all the data sources. Data mining results are stored in the data layer, so it can be presented to the end user in the form of reports or another kind of visualization. Data mining application layer is used to retrieve data from a database. Some transformation routine has to perform here to transform data into the desired format. Then we have to process data using various data mining algorithms. Next layer is front end layer. Front end layer provides the intuitive and friendly user interface for end user to interact with data mining system. Data mining result presented in visualization form to the user in the front end layer. To conclude, the architecture and design of a data mining system is important for data mining system. A good system architecture will facilitate the system to make best use of the software environment to accomplish data mining tasks in an efficient and a timely manner. Each and every component of a data mining system has its own role and importance in completing data mining efficiently. These different modules need to interact correctly with each other in order to complete the complex process of data mining successfully. Thank you.